and we will move right on into our next talk with Miller on enabling modern flight control and ground science support teams using software support systems.
Thanks, Ferris. Com check.
I can hear you just fine.
Perfect. Thanks, everyone. Hi, I'm Matthew Miller. I'm a research engineer at the Astromaterials Research and Exploration Science Division at NASA Johnson Space Center. And I'm going to talk today about how we're going about enabling modern flight control and ground science support teams using software support systems. Next slide. So just to kind of highlight the three big areas we're going to talk about today, we're going to highlight what we're calling the EVA Mission System Software Initiative, EMSS, which was plugged yesterday by Alex. And what EMSS is a cross-organizational team focused on the integration of cross-organizational software in the planning, training, execution, and exploration phases of both ISS and eventually Artemis. And as I said here, this is a multi-org, multi-NASA center effort already. We've got folks spanning JSC, Ames, Goddard, and we're looking forward to bringing in an even broader scientific community like everyone that's on this call. And one of the key things I want to emphasize here is this idea of incorporating this exploration science mindset into the flight mantra. And so this is just something that we've taken as part of the EMSS initiative here, is to think about this plan, train, fly, and what that looks like from an exploration perspective as well. So if we go to the next slide. And here's where we kind of highlight that, where when we think about it, as soon as data is acquired during a mission, we have this ability to start exploring it. And that's going to persist, throughout both during the mission and well post-mission, that will lead into, again, the next cycle of plan, train, fly efforts. And so when we think about it from this mantra, we started to ask ourselves what questions might persist throughout all of these phases that really gets to the nuts and bolts of what software should be helping us do. And these three questions here start to anchor some capabilities that we've started to develop. And they really speak to three things. Where are we? What are we doing? And what are we learning? And it's by answering these questions that we're ultimately going to be benefiting the ops community and the science community as we take on these future missions. So we go to the next slide. And to kind of put it in context, and I know we've seen some videos here previously, but if we take a snapshot of this data flow and the work involved in what that data flow entailed from Apollo, we can see here that the multi-layer process by which people literally took electrons and got it to the places that needed to go in order for people to make decisions, and how this data was disseminated amongst the larger flight team. And so if we go to the next slide, here we can start to think about data retrospectively, particularly in this horizontally integrated mindset. And to plug my colleague Cameron Pittman in the next talk, he'll dive deeper into what this means. But effectively, we can start to build the narrative based on time with disparate data sets. And so if you go to the next slide, many folks on this call is probably already familiar with the Apollo in real-time platform, which brings to life this concept where you've got disparate data sets pulled together temporally so that people can relive the context within which the mission took place. And so if you go to the next slide, here you can start to think about what does it mean to start pulling scientific data into the ops process. And so from just an exemplar of the Apollo in real time, you were able to start to link the moment that sample was taken to all subsequent events that occurred with that sample. You've got all your curation documentation that happened well post-mission. You've got all the publications that happened downstream, and you can pull that narrative all into the moment that it happened, the conversations that took place when it happened, the video and imagery that surrounded the moment in the mission that inception of data took place. And it's this integration of mission context that links this moment of inception to all subsequent advancements with that data that we might take. And it's really about enabling that. So if you go to the next slide. So when we pull it back to the three questions that the EMSS initiative is trying to take on, we can think about it from the first question of where are we? Unfortunately, particularly since Apollo, there's been 40, 50 years of geographic information systems development. So this is a billion-dollar industry. And we've started to pull in the relevant expertise to start thinking about how to leverage those modern day GIS tools for the needs of the EVA community. And one of the big challenges here is to start incorporating EVA constraints into these GIS platforms. And so here's some exemplars of prototype products that we've created that starts to incorporate map planning products, scientific data products, and operations and scientific data products all in the same map. And I know Fred yesterday really spoke to the brevity and sheer volume of kind of map data that will be necessary for future missions. And we're starting to leverage those robotic ops experiences for human spaceflight. Can you go to the next slide? Another big question, particularly pertinent to EVA, is what are we doing? For all of EVA history, we've been working under this paper-based product, very static paper-based products to execute EVA. And so we're starting for the first time to digitize that tool, those products, and put them into a medium which can be shared collaboratively in a digital way. So here's some examples of what we've got in current development called Maestro, which is actually starting to take paper-based products from ISS and putting them into a digital platform that's easily editable, can start to be used during execution, and really enable this idea of collaborating with the nitty-gritty EVA details of a timeline. Go to the next slide. And for the third question, we can start to think about what are we learning? And so this is starting to take this Apollo in real-time experience and put it into action, particularly with starting with ISS. So here we've got an example of a screenshot of our current tool called CODA that's starting to pull in disparate data sets from the ISS telemetry streams to start visualizing in this consolidated way so that folks can start to leverage this consolidated medium. And this is all coming particularly from decoupled data sources. And so when we start to think about what we're going to need for Artemis, this starts to pave the way for the kind of software requirements that we ultimately need to put in place now so that we're ready for the missions when they do come online. And what's interesting here is you're not only just starting to pull in just specifically audio, video, you can start to pull in photography, engineering and suit data, health and human performance data, scientific data. All of this can start to be brought together in a way that's accessible to a very broad community and be used for many different use cases. So we can go to the next slide. And so to kind of wrap up here, we've started 3 different initiatives to try and answer these questions of where are we, what are we doing, and what are we learning in an EVA context. We started to prototype specifically Maestro and CODA as 2 sort of backbone pieces of software that help us wrestle with these problems, and we're starting to turn on EVA GIS products, specifically through the use of EVA testing that Kelsey spoke to this morning. And then for future initiatives, we could really see the extensions of these 3 tools and probably tools that we haven't yet thought of that really start to pull in relevant data sources that's needed for the mission, particularly scientific data products. And so the idea here is that we can start to pull in and open up the ability for these software products to exchange data with each other so that you're not relying on some monolithic tool, but rather a diverse network of tools that would really meet the needs of the workers trying to support the mission. So if you can go to the next slide. And so just to kind of leave you with this concluding thought of, imagine if the Artemis crew, science team, MCC team, and members of the general public can all use this same system to support, or same ecosystem to support humanity's return to the moon and experience it together. And so with that, I'll go ahead and give my time back. And
all right, thank you so much. It was a fantastic talk.